You can think about this a few different ways. If you want to be really formal, you can do something you're going to do a lot when you get into integrating calculus. You can do a substitution. But the thing is, you want to think of cosine of theta as like a variable, like x, right? So x equals cosine of theta. And now this is a little easier to solve. We could use the quadratic formula, or if you were good at factoring, it's actually pretty simple. So I need a minus and a plus, and factors can only be 5 and 1, so you just have to figure out which goes where, right? Well, 5 goes here, and 1 goes here. If you kind of lost that skill, but you remember the quadratic formula, you're still golden. Right? Okay, so what does this tell me? What does factoring this tell me?
X has 2 possible answers. X has 2 possible answers.
Sure, x could be equal to 1, or x could be equal to -5. But x was not really what we wanted to find. We wanted to find theta. But this tells us right away 1 equals the cosine of theta, or cosine of theta equals -5. Well, we don't have to worry about this one, do we? Yeah. You can't get a theta for this. That's okay. It's just extraneous. You know, you've seen things like this before. I hope extraneous roots. You've seen extraneous roots. Anyone remember what an extraneous root is? Just in case. Maybe something like this, like square root of that's simple enough. I said square root of x squared equals 1, right? No, that's not going to work. I'll pick up with an extraneous root problem over the break. Okay. Oh, I did it. Oh, I didn't want to do it. Well, you still have one more. So why doesn't everybody take a shot at the last problem? And if you haven't done any of the other ones, give them a try now. And we'll go over anything that's troublesome. You need a sheet? I will look. I will see if I have more. Anyone else need one?
Yeah, I do. I think I forgot to grab one. I completely forgot about it.
Let's take a shot at the last one. While we're working on that, there's some other information up on the board. Today's date is the 5th. Is that right? Yes. Yeah. 5th. Thursday. Tuesday, the 17th, there will be a quiz on identities. And Thursday, 19th, will be review day. And Tuesday, '24th, will be the final.
What time?
Oh, when you what time?
Same time.
6 o'clock? Okay.
Yeah. I mean, if absolutely everybody in the class said, I'd much rather do it on Thursday, 26th, I could accommodate the whole class. But I can't do half and half. So,
There might be a release for the quiz on identities.
yeah. I mean, I'm working on it here. We're going to have some more identities.
Good, because I have identities. I was going to make a joke.
Okay, so let's say like x plus x. X squared minus x minus 2. Didn't work.
As far as you go on the stacking problems, find like that, it's like cosine of theta equals 1. That's the answer to the problem.
No. Theta equals what? 0.
Okay.
And does it? No, it doesn't change. Yeah, but also plus 360. I mean, you know, I didn't ask for all of them, but yeah.
They don't do finals on Mondays, that's right. It's only up the final one.
There we go. Extraneous root problem. So we say x squared equals the square root of 6 minus x. So how would we solve? Oh, x equals the square root of 6 minus x. So we say, all right, we're going to solve this by squaring both sides, right? So now we end up with x squared plus x minus 6 equals 0. And we get x plus 3 times x minus 2 equals 0. So we say, oh, x is equal to 2 and negative 3. Then we try and plug these back in. Well, 2 is equal to the square root of 6 minus 2. That's square root of 4. Yeah, that worked. Negative 3 equals the square root of 6 minus a minus 3. That's 9. That's equal to 3. Oh, that doesn't work. That's an extraneous root. It's not a solution, but it comes out of the process because when we square this, we kind of hide the fact that that's a different problem. We said x equals minus the square root of 6 minus x. Then 3 would be a root, but then 2 wouldn't be. Negative 3 would be a root, but 2 wouldn't. So I don't know if that is helpful. It's the same idea. It doesn't really matter. All I need is one of these to go to 0. I can't make this one go to 0 because I can't make the cosine equal to minus 5. But that's okay.
Did you have me working through
I'm sorry?
the last problem on the front of the page?
The negative 9.1, that guy?
Yes.
Oh, okay. So, negative 9.1 equals 1 over the sine of negative x minus 3.5. So we add 3.5 to both sides. Yeah. 1 over sine of negative x. Or I could find the reciprocal of both sides, and I'd get sine of negative x equals 1 over minus 5.6. And now here you want to jump in and say, sine of minus x, what's that?
Negative sine.
Negative sine of x. So I can nullify those negatives. And now I just need to find the inverse sine of this guy. Right? So what's that? Inverse sine 1 divided by 5.6. I get in degree mode, I think in degree mode. Yeah, I get 10 degrees. 10.2865 6061.
And then, did you find the additional?
Yeah, I'm sorry?
You find the additional values since it's the whole thing.
Yeah, you know, I wasn't real specific here, so you can get away with anything. I mean, if I wanted, you know, all the solutions, I'd say so. I was just more interested in the mechanics right now.
But you said find solutions over 0 choose for 60 on the board.
I'm sorry, I didn't.
But you said doing this range, right?
Oh, you're right. Thank you. See, reading directions is important. Yes. If you look above, the directions you want to find. Okay, so this is 10 points. We'll just say 2 8. And now, so that's kind of like over here in the first quadrant, and that's the sign. Well, where's the other one going to be? It's going to be the complement, so it's going to be 180 minus 10.28, whatever. It asks for it between 0 and 360, so you have to think, could it be down here? No. So there's just 2 answers. Thank you. Okay. Chris. If you turn it in, I'll take a look at it.
We're not required to.
You're not required to know. Okay. Before I get going, I'm going to take all this back. Just some miscellaneous homework. Okay, are we ready for more? Ready for a little more? Okay. So, I wanted to repeat myself. So not next Tuesday, but the following Tuesday we'll have a quiz on these identities. That'll be the last quiz, of course. The following Thursday, all-day review. I encourage you for the review to come in with questions. I'll prepare something, a review sheet, and go over that. But you're certainly welcome to, it's for you. And then of course the final.
On the final, everything be allowed notes?
Yeah, a sheet of this. We'll say 2 sides, okay?
Okay.
All right? Compressed down to minuscule size that.
But like a full, like a page?
Yeah, you can have two sides of a page.
2 sides of the page.
Or 2 pages,
One side of the
one side of each blank stapled together to be
That's a whole
final.
page.
Yeah. I mean, you understand, in math, you might remember how to do something, sort of, but you might need to look it up. Right? To me, that's knowing how to do something, using a reference. What we don't want you to do is bring in the book, right? And the things that you need to do the final probably fit on 2 sheets of paper, everything we've done in class, if you know how to do it. If you want someone to explain how to do it, you're supposed to, hopefully you're learning that in class. Okay, where am I? My notes. Okay. So the next The next identity we're going to learn is my favorite. Really the surprise.
Oh, I'm sorry.
What was it?
Take your lecture on that.
Oh, hold on. So, just like we were doing the other day with the odd, even, or the co-functions, you draw a nice little diagram here. You draw a triangle in the first quadrant. And you discover something really, if you don't know this, if you haven't seen this before, you kind of go, how did I miss this all my life? Or at least since the beginning of class. So we're going to call the radius of this circle r. Even, this is not a unit circle necessarily. This is the x-coordinate, of course. And the y-coordinate, right?
Isn't it the other way around?
Yeah, it is. Thank you. And we're going to write down a couple statements about this diagram. So first statement is the sine of the angle is just what? Just y over r. And likewise the cosine is x over r. So we can rewrite these as r sine theta equals y, and our cosine theta equals x. So now we want to write down our favorite theorem in geometry. Pythagorean theorem tells us that r squared equals x squared plus y squared. And so I want to substitute in r squared equals, well, this is r squared cosine squared plus r squared sine squared. So the magic is going to happen so fast that I want you to look at that for a second. Just, make sure, look at those steps. Right? So I'm going to divide both sides by r squared, and I'm going to get our magic identity. Okay. This is so closely related to this that it's called, I would call it the Pythagorean identity. In so many attempting to show some identity, this comes up as a simplification. You see cosine squared plus sine squared, you go, yay, I can simplify that to 1. It shows up in other forms too, though. If I subtract cosine from both sides, and add 1, and subtract 1 for both sides, and what am I trying to do here? 1. Sorry for being. If I solve for one of these guys, right, I get sine squared equals 1 minus cosine squared. So whenever you see this pop up when you're trying to do an identity, you go, aha, I can simplify. Or likewise, it's also nice if you can use this if you have a bunch of sines and cosines in a formula and you think, hey, if I could change them all to sines or all to cosines, I could simplify it, especially if it comes in this form of sine squared and cosine squared. We'll no doubt see some of those for day is over. Okay, so that's the Pythagorean identity. Let's put that up here. There's something else about this equation that I think bears noticing. Does this remind anybody of anything else they've ever run into in algebra or math? Just the form of this. Anybody remember seeing an equation like this? Anyone remember this? Okay. No.
Get over that?
Well, not since high school, but does anyone know what that's the graph of this looks like?
Is that a circle?
Yeah, that's just a circle with radius r.
This would be geometry.
Ooh. And since we know that the x and the y coordinates are the sine and the cosine, well, it's really, seems related, doesn't it?
Mm-hmm.
So, okay, a little aside. This is like foreshadowing. All the English majors in the room know what foreshadowing is. You don't need to know anything I say for the next 2 minutes. If you remember this equation, you might remember what the graph of this is. We'll just say, I won't say r squared. Let's just say 1. Or 1 squared. Do you recall what that is? We're going to take calculus, go back and review your high school algebra. You remember what this is?
Wouldn't that be a circle with radius 1?
No. That's a circle. Here. That's a circle with radius 1.
Oh, minus.
Minus, yeah. You guys you didn't do this. Conic sections, do you remember conic sections?
Didn't learn.
I remember the word.
I remember the word.
Conic. I'll write it. It's awfully close to comic, isn't it?
No.
Conic sections. Well,
I remember not.
Yeah.
well, you'll learn to love conic sections. Well, of course, you've all done like 1,000 times y equals x squared. That's your parabola. And did your circle, and then they, oh, and does anyone remember this one? X squared over a squared plus y squared over b squared equals 1. Anyone remember that one?
It's an ellipse.
Yeah.
It's an ellipse with major and minor axes A and B. And if you make that a minus, you're back, you have another
Hyperbola?
okay, it's called a hyperbola. Right? Hyperbola. If you draw your circle, that would be there if it's a plus, kind of ends up like this. And actually, usually the way we graph it, we draw a little box here with major and minor axes, and we draw these lines. And it turns out, actually to draw it nice, these are asymptotic. Anyone remember what asymptotic means? the hyperbola gets closer and closer to these axes. Okay, like I said, you don't really have to know anything about it. But the reason I bring this up is if there are these functions, sine and cosine, that have something to do with this, you might wonder if there are functions that have to do with this. And in fact, there are. They're called the hyperbolic sine and the hyperbolic cosine. And they have a different identity than this. Their identity is hyperbolic cosine squared minus hyperbolic sine squared. Got the right place. Is equal to 1. And these become very important in calculus. And you don't really have to learn about them now, but foreshadowing. Okay. All right. I'll just like this stuff, so I'll just hide it here. All right. So we have our the Pythagorean theorem, the Pythagorean identity. We're going to add a couple more. And we're going to do it very, equals 1. We're going to do it very simply. First step, divide both sides by cosine squared. Okay, so we want to rewrite these in a simpler way. Sine squared over cosine squared, that has to be tangent squared plus, what's this? 1. And we have a name for 1 over cosine squared, secant squared. So now, just like with cosine squared and sine squared, if you see a tangent squared or a secant squared floating around, you want to think, I wonder if there's a substitution here that's going to help me. That up here. There's one more thing we can do here. Pull out another identity. Instead of dividing by cosine squared, divide by sine. Okay, and then I'm going to get 1 plus cotangent squared. It's going to be equal to cosecant squared. Everybody who hasn't done it, try and do that in your head. Build up that mathematical muscle. Okay, so I'm not going to write it that way. This way, cotangent squared 1 cosecant squared. All right, so those are our. I guess I was doing this in blue, but these are our Pythagorean. You can thank Pythagoras again. Pythagorean identities. I don't know if it's going to come up in this class. There's one more trick. I showed you that sine squared equals 1 minus cosine squared. But that also means that we could substitute sine of x equal to the square root of 1 minus cosine squared x. That definitely will come in handy in calculus. I don't know if we have any like that in this class. Okay, let's do a real problem here.
Seven.
Oh, thank you. Time for a break. Let's have a break for maybe 10 minutes. Okay. Anybody who came in late and had questions about the quiz, you want to come ask me now. After the break, fun with Pythagorean identities.
Next one is yeah.
And not like static or something or whatever.
9:30 is
You know how it is? What do you think, Ray? Very friendship maker? By the way, you know who's winning? By the way, you know who we make it feel all? Avenger. I mean, weapons are even very, can be very out of the way. They even break a few times. Yes.
Walking is slow. If you're going slow, 15 minutes. If you're on hand, if you're in the average, like a brisk pace. People are paying to. It sounds like a good career choice. Yeah. And maybe I think I don't know what they do in that
Letter.
setup.
Right?
I think they do. You have to call them. And it has, or generally it's up as A, B, C. It's three levels. Well, maybe I can do the setup.
Okay, so let's just take a look at two examples where the Pythagorean identity or identities would come in handy. What's screaming at you on this one? Yeah, where, when, what? What do I want to do here?
Change it to sine squared theta. Change it to sine squared theta.
Does everybody see that? 1 minus cosine squared theta. Threaten you with this. That's just sine squared theta. Okay.
Sine squared theta.
Cotangent squared theta. What do I want to do now?
Change it to cosine and sine.
Change it all to sines and cosines. This is a strategy. It doesn't always work. Not always the thing to do, but in this case, sure looks like a good start. Okay, so this is sine squared theta. Cotangent is going to be what?
Cosine squared theta.
Cosine squared theta over sine squared theta. Right? And now I'm just left with cosine squared theta. That one's pretty easy. This one is, oh, I have to erase this first. This next one, hopefully will remind you of something else from algebra that hopefully has been burnt into your memory. Even though it's kind of a new environment we're seeing it in here. Okay. What am I blabbering about here?
Secant squared theta.
Well, it's already factored.
Or, sorry.
You want me to multiply it out?
Distribute.
Right. So does anyone remember the little magic about something plus something times something minus something?
Secant squared theta minus tangent squared theta.
Yeah, if I have A plus B times A minus B, this is kind of like an identity, huh? Okay, so secant squared theta minus tangent squared theta. Okay. All right. Now, there are two directions you could go in. There's at least three. You could fall back on sines and cosines. Let's see where that takes us. Secant squared is 1 over cosine squared plus tangent squared is sine squared over the cosine squared. So it's 1 plus sine squared over the cosine squared. Wait, is it minus?
Yeah.
Minus? Oh, sorry, minus. Okay, 1 minus sine squared over cosine squared. Well, what's 1 minus sine squared?
Cosine squared.
Cosine squared. So this is just going to be cosine squared over cosine squared. Of course, it's 1. That's one direction you could take. Another is you could kind of look at one of these
Secant squared theta equals
alternates, right? Secant squared is tangent squared plus 1, right? So tangent squared plus 1 minus tangent squared, that's just 1, right? It's a little more direct. You could use this one too. Oh, no, we didn't use that one. Is there anything else? No, I guess you could say tangent. We could solve for tangent squared. It's the same thing. Same Okay. So, the best way to learn about these is to practice them. So, of course, I have something to practice with. So, there's only 5 problems on here, but they're all Pythagorean identity. So, give them a shot. There are 2 there. For you. Oh, you have an X. Oh. All right. I hope no one will be thrown for a loop by the liberal use of Greek letters here. Are you familiar with alpha?
Yep. 1 minus c squared.
I don't know what that one is. Like phi?
Yeah.
You spell that in English. Thi?
Minus cosine times secant.
I guess if you go to a private college with a fraternity system, you learn all these things real quick.
My cosecant. It can't.
Phi beta kappa. There we go. Everyone know what phi beta kappa is?
No.
I don't either. But I hear it all the time. It's an honor, I think it's an honor society. Greek. Yeah, I mean, in fraternities, for some reason, they use Greek letters. I'm not advocating fraternities, by the way. I was not a member of a fraternity. The school I went to did not have fraternities. You probably never heard of it. A little school in the east. It's called Haverford. No. It's in Pennsylvania near Philadelphia. We had a sister school people have all heard of. It's called, and if you go to a school next to this school, you have to learn how to pronounce it in a snooty way. Bryn Mawr. Bryn Mawr is where Catherine Hepburn went to school. Yes. And if you don't say it with a snooty accent, then yeah.
Part of the curriculum when you're
You don't get any dates on Saturday night.
Oh.
Yes. Yes. Yeah. Well, it's not done. So now this equals 0, right? So that means either this is 0 or this is 0. Well, this is going to tell you that the cosine is equal to -5, which is never going to happen. This one's going to tell you the cosine is equal to 1. So you do kind of need the inverse cosine, but you should know when the cosine is 1. I don't think if anybody famous ever went there. Oh yeah, yeah. You know who went there and dropped out?
No.
Chevy Chase. Let's see. You know who Bill Murray is? Bill Murray. Have you you ever heard of a TV show called Saturday Night Live?
I'm just missing it out of my office. I don't watch TV at all.
Well, that's good, because the more TV you watch, the stupider you get.
No, that's only if you watch reality TV shows.
Yeah.
But especially from anything on MTV.
Yeah, there was he was one of the early, there's a whole bunch of Saturday Night Live characters. It's been on for like, I think 40 years now. But the original crew is really, really good. Just like John, you heard of John Belushi? Oh, okay, so don't watch TV, but watch a movie called Animal House.
Animal House.
Animal House.
Animal House.
Animal House.
Animal House.
Watch it.
Yeah, watch Animal House.
Watch it.
Okay.
And
They have YouTube, right? YouTube? What do they have on YouTube?
I don't think so. They might have some scenes from it.
Oh.
But Chevy Chase was one of these guys, but all his movies were. His movies aren't any good, but he's very funny. And he dropped out before I got there.
Who's very fun?
Chevy Chase went to my college, but he didn't graduate. He dropped out, which is probably good for him.
You can take my notes. Yes. Yes, one of them.
Okay, let's see.
Okay? Did you do them all?
Okay. Switch up.
Can't say.
How come no one's doing what mine can do?
So,
I can hit it.
so I have a question. And I'm going to apparently be teaching, I guess I didn't, do anything bad enough yet that they decided to get rid of me. So I'm going to be back, I'm going to teach B next quarter. And I'm curious, B, 48B.
Oh,
This is C, I'm moving backwards. So, and I'm not referring to anyone specifically, but there have been a few students who, at least in one case, as someone who's not here, I know is having trouble because of their job, they can't get here. And I know that's kind of weird. I mean, some of you are here because you have jobs during the day, right? At least some of you, right? And it just kind of strikes me, what is it, how is it that, you have a job? I guess some jobs are like that. They're just like random things happen and you have to be there late or something. I mean,
Sometimes they ignore your availability and schedule you anyway.
I'm sorry?
Sometimes they ignore your availability and schedule you anyway.
Oh, I see, and your choices are to defy them and get fired or to skip class.
Yep.
Oh. Yeah. Well, nobody say anything now, but if you have suggestions for things I can do as a teacher of a class that students who work take, if you have suggestions like how I can, I mean, I don't know, does everybody know, like the videotapes aren't very good, but I do videotape them and put them up so at least you can see what happened in class. And I put my notes up. If there's anything anybody can suggest that I can do to make it, easier is not the word I'm thinking of, but, doable if you're in that situation.
I think maybe you should put the camera a little closer to you.
Yeah, but where? Like in the middle of the class?
Or maybe you should zoom in a bit more. Maybe zoom in a bit more then.
Well, then I'm kind of limited to what I can
Yeah, but you do,
I could do that, I can limit myself to this board. I could limit myself to this board. Okay.
I'm being silly.
Well, I'll tell you what, I'll go back and readjust. We'll see how that works.
besides, I think the wall, in the footage, so maybe at least doing a little.
Okay. Hey, that's really interesting.
Oh, you moved yeah, where did
I think once you get used to these identity things, they're just kind of like algebra, you know, like polynomials. You know, they're not really much harder than that. That's my plan.
well, it says your way is right. Silver edition. This edition I am not sure all of this. But it's still the same font. Other than the silver and square. This is, I mean, they're the same thing. This is still a the silver edition does have this.
What you just did was probably good. We can get on. Pretty easy, but
It's like salty. I do get like little points.
That one's great.
I have one question.
This one's great.
Is your
Yeah, this one's fun.
arrow
This one's new, so back in
infinity signs? Okay, everyone, let's, if you're having lots of trouble with these, you probably need some help, and if you're all done, you probably want to see how some of these are done. Okay, so secant squared. Learn our three ABCs this way, maybe. Sine squared. Okay, so was there anything to this one, or was this one really simple? That's secant squared is just 1 over cosine, and 1 minus sine squared is so it's another one of those in 1, right? Well, that was too easy, wasn't it? Oh, it was the first problem, so we want to go an easy problem so that they. Okay, number 2. We have secant squared. Another Greek letter, the phi. Minus 1 over sine squared. So immediately you look at this and you think, gee, I wonder, is that one of those, since we're doing Pythagorean identities, does that look like anything over here? Well, it kind of looks like this one, except the one's on the other side, right? Until you subtract it, right? So secant squared minus 1 is just what? I know you're kind of at a sharp angle.
No, I have the
But that's
trig identities on.
Oh, okay, all right. Yeah. So what's secant squared minus 1? Tangent squared. And now the obvious thing to do is to write tangent as what? Sine squared or cosine squared. And this is just 1 over sine squared. These guys cancel. We have 1 over cosine squared, but we like to write that as secant squared. Okay, so far, not too hard. Okay, I think actually the next one is, given we just did this one, it's almost too easy, right? Secant, I'm not even going to write the letter at this point, the variable. Secant plus 1 times secant minus 1 is, of course, secant squared minus 1. Can we just do that? That's just tangent squared. Right. Okay, the next two, we're not asking you to simplify, we're asking you to solve an equation. Okay, so again, take a trip down algebra memory lane, right? Seems kind of artificial. It's like, well, duh, add 2 to both sides and Just got a 1 over there, right? All right, what?
That would be
Minus 3?
-3.
Oh, -3, oh. This is what happens when you do math for too long. Your brain goes to Swiss cheese. You can't even add 1 and 2 properly. Okay, so what am I going to do here? What does this look like? What does this look like? Cosine squared. Cosine over cosine squared is just 1 over cosine. So this is just secant. And really theta is the secant inverse of -3, but that's just what? Cosine inverse of okay. This didn't say anything about solve for all values, so just whatever the calculator pops out would be fine in this case. All right. So the last one's a hard one, is that right? I hope it's really, really hard. You know why?
Why?
Because I have to spend the rest of the period doing it. 35 minutes.
It's not that hard.
It's not hard enough?
Oh, yeah. It's so hard. What do you want to do that?
Miscalculated. I thought people would be asking lots and lots of questions about the quiz and about that other sheet, but it's all right. Cotangent squared theta equals 0.8. Oh man, what am I going to do with this? Well, knee-jerk reaction. Change everything to sines and cosines, just to see if that helps. If it doesn't help, well, then you can always go back. Sorry? Heard something. I didn't hear.
That's kind of hard to resolve.
Oh, all right. That's okay. Skip a step. What's the cotangent? Cotangent is cosine, so cosine squared, sine squared, it's 0.8. Well, obviously I'm going to cancel that. Then I'm left with 1 minus cosine squared, and that is sine squared. Okay, so what would I do now? You would, but you want to be careful here. I'll take the square root of this, that's obviously the sine of theta. What happens over here? Is that what I want? No, I want 4. It's really plus or minus, isn't it?
Oh, it is?
Well, if I take this plus or minus 0.8 and I square it, I'm going to get 0.8. So either of these would work. So I have sine of theta equals the positive square root of 0.8, and sine of theta equals the negative square root of 0.8. All right, let's see what we get from our magical calculator on these. Well, inverse sine of that, right? Sine of square root of 0.8. Apparently I'm fading because I didn't bother to turn the thing on.
Fading or failing?
fading.
Yeah, but the both are so important.
Okay, so for the positive, I get 63.843. And for the negative, I get negative 63.43. But of course, there are more answers, aren't there?
Goes on infinitely.
Well, let's just take a look first. We've got like 63 degrees here for the sine, right? Sine is this, so we also have this one here, right? That's the complement. 180 minus 63.43. This guy's down here. Same thing, right? So I guess it's just the negative of this, isn't it? So you can write it. Find a cheap way to find the negative, 63.43 minus 180. So I've got four numbers here, and then to each of them I could add what? 360.
Well, since it's in every quadrant, you can just do, since there's an angle in every quadrant that satisfies it, can't you just add 90 to the first one? Plus 90?
No, it's not 90.
Oh, it's not, yeah.
It's not. It's this is 63.43.
So
This one, this angle is 63.43. So the angle is actually 180 minus 63.43. That would only be true if it was 45 degrees. Then you could add 90.
But then you can just take like the first two, the first quadrant one and add 180, and then take the second quadrant one and add 180. Then you'll know.
No, that doesn't work. No. The first quadrant one is here, and the second quadrant one is 180 minus this. So.
No, I'm saying to find the third quadrant one, we just take the
To find the third quadrant one? Oh, yeah, it's
yeah.
yes, that's true. You could just add 180. You could add 180 to this,
And 180 to that.
and 180 to that. Right. Yes, that would be a good simplification of the answer.
Would you get the same answer so in the beginning where it says 1 minus sine squared, if you change that to a cosine squared and you cancel out the cosine instead?
That won't work.
Like I was getting it.
I didn't understand.
You're running through his
I
order.
didn't understand it, but I'm intrigued here.
What he's saying?
1 minus sine squared,
Order of
cotangent squared equals 0.8. Okay, go ahead. Tell me again.
Oh, okay.
What did you want to substitute?
Well, I'm converting that into cos, because that equals cosine squared, right? But
but no.
Yes.
Yeah, there's just no room.
Right? It's not. I mean, if this were the case, yes, you could. But
Okay, yes.
however, just, because fooling around with math is part of the game, right? So if I drew these here, that's not the same as what I had before, but how does it differ? Well, this is now,
Cosine.
there's an extra cotangent squared in there, right? So I have to, right? Did that sleight of hand make sense to anybody? Did I do it right? I'm saying, if I put these in, right, what have I done? I've added a cotangent squared, so I'll just subtract it. And now I'll try what you were saying. So cosine squared theta, cotangent squared theta. I may be just wasting time here. All right. Yeah, I think I end up back where I started from because, I mean, what am I going to do with this? Well, all right, let's see. Cosine squared theta times cotangent. Oh, that's cosine squared theta over sine squared. Well, this is going to be over sine squared 2 minus cosine squared. I think I am wasting my time, but if I now multiply this, you know, by sine squared over sine squared, and subtract it, I have minus 0.8 sine squared equals 0. And now I want to change sine squared to cosine squared, so that's times 1 minus cosine squared. Yes, I've managed to make this into, and then if I multiply by sine squared, it goes away, right? I've managed to make this into a quadratic. Well, not a quadratic, a quartic. Cosine to the 4th theta minus, let's see, minus cosine minus 0.8, oh, plus, so now it's plus 0.2 cosine squared theta. And I still have a minus 0.8 equals 0. So I could factor this. Do that. I could factor this. All right, this is cosine squared theta equals, and now I use the quadratic formula, negative 0.2 plus or minus the square root of 0.2 squared plus 4 times 0.8 over 2. Okay. Wait a minute. Yeah. So this is 0.04. Negative 0.2 plus or minus the square root of 5.2 over 2, or negative 0.1 plus or minus the square root of, I divide that by 4, 1.3, and that's the cosine squared. So the cosine will be plus or minus the square root of negative 0.1 plus or minus the square root of 1.3, and I'll get 4 answers, and who knows? Anyone want to see if this, it might go nowhere. It might be I did it wrong. Obviously, it was much more difficult than the other way. But it's intriguing because it has 4 answers, and that's kind of what we see up there, isn't it? Yeah, it might be. All right. I'm not going to do a song and dance here. We're kind of. And add a material. I don't want to go on any further today. We're going to have 2 more days of identities. There's a whole bunch of neat and useful ones. They're not just for playing around with. We'll do those Tuesday and Thursday, and then I'll have a quiz on Tuesday. And that's kind of wrapping it up. I'll